Good day everyone. I'm Jowelah Dominguez, BSFI-2C. Today I will be talking about timeline of microscopy history. So what is microscope? Microscopes let us view an invisible world, the objects around us that are too small to be seen with the naked eye. These timelines provide a look at some of the key advances in microscopy. 710 before Christ Nimrod lens. It is a piece of rock crystals, may have been used as a magnifying glass or as a burning glass to start fire by concentrating sunlight. It is later unearthed by Austin Henry Layard at the Assyrian Palace of Nimrod in modern-day era. 1000 Anno Domini Reading Stone. The first vision aid called a reading stone is invented. It is a glass sphere placed on top of text which it magnifies to aid readability. 1021 AD Book of Optics. A Muslim scholar, Al-Haytham, writes his Book of Optics. It eventually transforms how light and vision are understood. 1284 First eyeglasses. Salvino de Armates is credited with inventing the first wearable eyeglasses. 1590 Early microscopes. Zacharias Janssen and his son Hans placed multiple lenses in a tube. They observed that view objects in front of the tube appear greatly enlarged. This is a forerunner of the compound microscope and the telescope. 1609 Compound microscope. Galileo Galilei develops a compound microscope with a convex and concave lens. 1625 First use of terms microscope. Giovanni Faber coins the names microscopes for Galileo Galilei's compound microscopes. 1665 First use of term cells. English scientist Robert Hooke publishes Microscopia, in which he coined the term cells when describing tissue. The book includes drawings of hairs on a nettle and the honeycomb structure of cork. He used a simple single-lens microscope illuminated by a candle. 1676 Living cells first seen. Anthony van Leeuwenhoek builds a simple microscope with one lens to examine blood, yeast, and insects. He is the first to describe cells and bacteria. He invents new methods for making lenses that allow for magnification up to 270 times. 1830s Spherical aberration solved. Joseph Jackson Lester reduced spherical aberration, which produce a perfect image by using several weak lenses together at certain distances to give good magnification without blurring the image. 1874 Abbe equation. Ernst Abbe writes a mathematical formula that correlates resolving power to the wavelength of light. Abbe's formula makes it possible to calculate the theoretical maximum resolution of microscope. 1931 Transmission electrons microscope. Ernst Ruska and Max Knoll designed and built the first transmission electrons microscope based on idea of Laius Szilard. The electron microscopes depends on electron, not light, to view an object. Modern TAMS can visualize objects as small as the diameter of an atom. 1932 Phase contrast microscope. Fritzer Nix developed phase contrast illumination, which allows the imaging of transparent sample by using interference rather than absorption of light. Transparent samples such as cells can be imaged without having used staining techniques. 1942 Scanning Electron Microscope. Ernst Ruska built the first scanning electrons microscope, which transmits a beam of electrons across the surface of a specimen. 1957 Confocal Imaging Principle. Marvin Minsky presents the principles of confocal imaging. Using a scanning point of light, confocal microscopy gives slightly higher resolution than conventional light microscopy and make it easier to view virtual slices through a thick specimen. 1962 Green fluorescent protein GFP discovered. Osamu Shikamura, Frank Johnson, and Yu Saiga discovered green fluorescent protein GFP in the jellyfish Aquaria victoria. GFP fluoresces bright green when exposed to blue light. 1972 First CT scanner. Godfrey Hounsfield and Alan Cormack developed the computerized axial tomography scanner with the help of a computer. The device combines many X-ray images to generate cross-sectional views as well as three-dimensional image of internal organs and structure. 1973 Electron backscatter patterns observed. John Venables and C.J. Harland observed electrons backscatter patterns in the scanning electrons microscope. EBSP provides quantitative microstructural information about the crystallographic nature of metals, minerals, semiconductors, and ceramics. 1978 Confocal laser scanning microscopes. Thomas and Christoph Kramer developed the first practical confocal laser scanning microscope, which scans an object using a focused laser beam. 1981 Scanning tunneling microscope. Gerd Wenig and Heinrich Roher invent the scanning tunneling microscope. The STM sees by measuring interaction between atoms rather than by using light or electrons. It can be visualized individual atoms within materials. 1986 Nobel Prize for Microscopy. The Nobel Prize in Physics is awarded jointly to Ernst Ruska for his work on the electron microscope and to Gerd Wenig and Heinrich Roher for the scanning tunneling microscope. 1992 Green fluorescent protein GFP clone. Douglas Fraser reports the cloning of GFP. This opens the way to widespread use of GFP and its tetrapeptides as labels for fluorescence microscopy, particularly confocal laser scanning fluorescence microscopy. 1993 to 1996 Super resolution microscopy. Stefan Hell pioneers a new optical microscope technology that allows the capture of image with a higher resolution than was previously possible. This results in a wide array of high resolution optical methodologies collectively termed super resolution microscopy. 2010 Atoms of a virus scene. Researchers at UCLA use a cryo-electron microscope to see the atoms of a virus. 2014 Chemistry Nobel Prize for Super Microscopes. Nobel Prize in Chemistry awarded to Eric Bitzig, Stefan Hell, and William Mowerner for the development of super resolved fluorescence microscopy, which allows microscopes to now see matter smaller than 0.2 micrometers. Thank you for watching. I hope you enjoyed.